Yeah, the title of my talk is Evidence for Massive Explosions on Mars in the Past. That shouldn't surprise anyone. Mars is next to the asteroid belt. We'll discuss that. Okay, we live in a violent universe. We just recently recorded the brightest of all time gamma ray burster. It probably sterilized the entire galaxy it was in. We're talking about if there was biology out there, it's gone now. So we live in a universe that's both dangerous and beautiful. Okay, this is our planet. You notice the Sahara and the Kalahari deserts on Africa, Arabia, bright red. Places where the earth is not covered with clouds or ocean. We have a bright red landscape. If everything on earth died, the oceans dried up, the atmosphere is gone, we would look just like Mars. Okay, this is the first Earth-like planet in the rest of the cosmos. It's close by. It's fairly user-friendly. We can survive on its surface as opposed to like Venus. So I'll be talking today about Mars past and present. Mars seems to have gone through a catastrophic climate change. So what destroyed Mars? I'll be discussing Xenon evidence of what's called an R process, it's a nuclear process, and Krypton evidence for the same process. R process, I'll explain, it means rapid nuclear process. And then nitrogen and argon isotopes, potassium and thorium on Mars. Energy release estimates for these R process events, and then a summary. An R process event, by the way, is like a supernova. It's a process where you have intense bombardment of heavy elements with high energy neutrons. But we'll get to that in a minute. On Mars, we find a lot of extinct water channels. You see this landscape, notice it has hardly any craters. In fact, there are no craters even visible. Something wiped away all those craters. This looks almost like an Earth-like landscape, and what it is a fossilized oxbow lake on Mars. A river flowed for millions of years and then formed an oxbow, and then finally short-circuited like it does in the Mississippi Valley or the Amur River or any of the large river systems on Earth that are very mature. So Mars past was much more Earth-like for a long period, billions of years perhaps. This is what ancient Mars looked like. A paleo-ocean in the north, and then less water in the south, and then perhaps a big south polar cap. Okay, Mars polar lander results. We explored that old ocean bed. Mars polar lander lands in the north on the old ocean bed. Water ice was found just a few inches under the surface. The soil was verified to be not toxic, could support life. Soil was consistent with an old ocean bed. It's got salt, it was salty. So the old Mars ocean hypothesis was confirmed, essentially. What changed Mars from being a planet that looked a lot like Earth to being what it does now? Well, Mars is next to the asteroid belt. This is the Leo impact crater in the north of Mars. Now, how do you think the Mars ocean bed was found? Look at this change in transition at the same elevation contour. Look at the change in terrain from being very having a lot of fine detail to suddenly being just mud flats. This is where the ocean shoreline apparently was. This thing hit on the ocean shoreline. It's as big as Chicxulub is on Earth, the Chicxulub crater that wiped out the dinosaurs. So Mars possibly went through a dramatic climatic change due to this Leo impact. Just about the time the Leo impact seems to have formed. And if you'll notice there are no craters around it. There are no craters inside of it. This is a very young crater. They estimate less than 500 million years old. So they look at the age of terrains relatively by crater counting. And they found that a lot of the old terrains were heavily water eroded. There's a lot of water erosion until roughly the epoch of the Leo impact. It dropped very low, and then Mars recovered, just like it did after the Chicxulub impact. So Mars was accident prone. It's next to the asteroid belt. But even an impact as large as the one that wiped out the dinosaurs was not sufficient, apparently, to change Mars' climate catastrophically so that it couldn't recover. We're talking a real catastrophe. So Mars died. Why did Mars die? Evidence of a massive nuclear event on Mars 180 million years ago. If you don't believe me, just check the references that I've given with the abstract. Also, you can find this on the net. The evidence, Xenon 129 spike in the atmosphere, very characteristic spike. I spent 10 years at nuclear weapons labs, Lawrence Livermore and then Sandia Albuquerque. I didn't work directly on nuclear weapons, but they worked just down the hall from me. We had some very interesting conversations at the coffee machine. And I was informed by one of them that Mars xenon isotopes meant that there had been a large nuclear weapons-like effect on Mars, causing that Xenon 129 spike. Here's Earth's xenon. It peaks at 129, also peaks at 132. 132 is slightly more than the 129. And that's common to the solar wind. Parachuted probe into Jupiter, same thing. They take all the meteorites and grind them up. That's what they get. That's the Earth is basically baseline on xenon. On Mars, however, you have 2.5 times more xenon 129 than you do 132. Very anomalous. Now, we had a meteorite that came in, in 1969, it fell near in the Chihuahua state in Old Mexico. It's called Allende. It exploded in midair. Hundreds of fragments are recovered. It's very ancient, very primordial. It was full of not only clay, hydrated clay, and tar, organic matter. It's the most studied meteorite in history, by the way. And it had a bunch of pre-solar grains, apparently grains that were older than the solar system itself. The main rock was about 4.5 billion years old, age of the solar system, but there were rocks in there, pebbles, that were even older. Now, when they looked at the xenon in those, they found out that there was this big spike in xenon 129. This rock has never been to Mars. They can tell Mars rocks from rocks like Allende by oxygen isotopes. Completely unrelated. But this meteorite apparently contained pre-solar grains, and what it does is it shows that that the pre-solar dust was full of supernova products of a supernova explosion. Supernova explosions are characterized by intense radiation of heavy elements in the core of the supernova, where uranium and all these heavy elements accumulate, and then the thing implodes. You have an intense burst of fusion neutrons that blows up the whole place and also splits a lot of those heavy things. And it causes what's called R process, rapid nuclear processes. So this is what the output from simulations of a supernova look like. They give a big spike at xenon 129. not as big as the one found at Mars, and then also 132. So, oops. So we have something from outer space that looks like Mars atmosphere as far as xenon isotopes, which are the heaviest of the inert gases. And but it never went to Mars. So a conventional model of Xenon 120, how did Mars get this Xenon 129 according to mainstream Mars community? Well, it had an early atmosphere. And then something happened, and during the early bombardment period, and the early atmosphere was lost, along with its kind of normative xenon isotopes and other isotopes. And instead, it was like the moon, and then it outgassed some more. Xenon 129 decayed, which has a 16 million year half-life. So you had an atmosphere that was enriched in Xenon 129 because of the iodinic decay. So it formed a new thin atmosphere. And then Mars proceeded just with a thin atmosphere. No, that can't be true. For one thing, the decay of plutonium-244, which is another product of supernovas, but it lasts 80 million years. It would decay also. It produces a lot of xenon 132. And other uranium and thorium isotopes would also, I guess, making the xenon 129 and 132 roughly one, just like it is on Earth. And here is the output of xenon isotopes from decay of plutonium-244, the circles, and you can see it gives a peak at 132, and then some others are also, but it gives higher weight xenon than the xenon 129. So they see abundant, they don't see any sign of the xenon, of the plutonium-244 outgassing, which from its decay, even though it would have happened at about the same time as the iodine decay. So, big mystery. When did the xenon 129 excess appear on Mars? Based on the age of the meteorites, the most primitive meteorites, ALH 8401 and Chisigney, which is a green olivine rock, never exposed to water, primitive meteorite. This thing happened recently in geologic time. There's no sign of the xenon excess, xenon 129 excess in the very ancient meteorites samples. It's all in the modern young meteorites, which crystallized maybe 200 million years ago. There's 129, and here's 136, which is due to like plutonium-244 decay, uranium decay, thorium decay. This is the fission, spontaneous fission. So there's plenty of that, even in the old Mars meteorites, trapped gases from the atmosphere, but the xenon 129 is not there. Now, could there have been a natural nuclear reactor on Mars? Well, that requires thermalized neutrons. We know that that happened on Earth. Had rich uranium deposits a billion years ago, enriched uranium. Water got into the deposits, formed a moderating influence. Natural nuclear reactor happened. Then the rock got hot because it was making a lot of heat, drove the water out, the reactor shut down. Cooled off, then the water infiltrated back in, the whole process started over again, over and over. So until it finally depleted the amount of uranium-235. You have to have thermalized neutrons to run a natural nuclear reactor, and it has to run in the dirt, in the ground. Now, our process, so that produces what's called S process, which produces a lot of xenon 132. Everything's normed to that. So xenon 132 is 1 if it was listed in this chart. Xenon 129, hardly any. So we know whatever happened on Mars was not a natural nuclear reactor using thermalized neutrons. It was an R process. Whoops. These new computers are very sensitive. All you have to do is look at them hard and suddenly react, trying to read your thoughts. Okay, Xenon 129 over 132 for R process, rapid process, intense bombardment of heavy elements by high energy neutrons from fusion. The supernova collapses, it burns up all of its fusion fuel at once, and then it creates a lot of fission. It also builds up some uranium, transuranium elements. It produces 1.5 times as much Xenon 129 as it does 132. You'll notice also some 131, but generally it peaks around 129. And then there's some minor contributions down here at lower isotopic numbers. These are the only two known events that create our process. One we have seen on Earth, the other we've seen the stars. There may be some natural process. Like I said, these computers are so sensitive now. Look at this. Calm down, computer. Take some Valium. Anyway, so there may be a natural process that we don't know about, some freak thing involving, I'm a plasma physicist. I trained to work on control fusion. It could be some weird solar flare effect that creates fusion. Who knows? It's a plasma process. Who knows? Some unknown event may actually create these R process events that we do not even know about. Okay, if we look at the Krypton, there's evidence of a lot of fission associated with this R process event. One of the other products of fission is Krypton. It's an inert gas, so we can track it easily because it doesn't combine anything, just outgasses. Krypton 80 is formed by intense neutron bombardment of rock. It's produced by capture of neutrons, thermalized neutrons. The neutrons last 10 minutes. They hit the rock, they rattle around in there, they slow down, and then they do what's called thermalized reactions, low energy. So bromine 79 really likes neutrons. It likes to grab onto a neutron and become Krypton 80, a gas, which then bubbles out of the rock. Neutron fluence of 10 to the 15th centimeters was required on the Martian rock to do this, to see what they had observed. They had to put samples of rock in nuclear reactors and irradiate them to get what they saw. So there was a massive neutron irradiation event, along with this R process that created the Xenon 129. Also, the rest of the Krypton isotopes are also affected. This is air on Earth, baseline. This is the sun, a nuclear furnace. The upper, and Mars looks like Krypton from the sun, a nuclear furnace. It's reverse fractionated. Normally you find the heavier isotopes concentrated instead of the lighter isotopes, because the lighter isotopes escape into space due to plasma processes, plasma scrape off, things like that, especially on Mars with the magnetosphere. Mars, Krypton is reverse fractionated. The light stuff dominates, particularly Krypton 80. That means a nuclear process. A massive nuclear process has to have occurred. If you sample rocks, these Krypton from Mars meteorites at various ages, they can estimate the amount of primordial xenon there was on Mars. Some of it looks like the solar wind, like the sun. Some of it is very much enhanced in Krypton 80, which is the result of bombardment of rocks by neutrons. But in general, it is reverse fractionated. So what? 5 minutes? Okay, thank you. So yes, so you can correlate the Xenon 129 excess and the Krypton anomaly, and they track. Whatever event created all the Xenon 129 also seems to have created the Krypton anomalies we see, and then formed a mixing line. So modern atmosphere full of Krypton isotopes, disturbed from Earth and Earth pattern, and lots of Xenon 129, whereas the earliest rocks looked a lot like the Earth's atmosphere. Pretty much normal Xenon and Krypton levels. So, other isotopic systems. If you look at the isotopes on Mars, two things stick out like sore thumbs. One is nitrogen 14 over nitrogen 15. The ratio on Earth is 252, meaning a lot of nitrogen 14. On Mars, however, it's much lower, dramatically lower. And that's because nitrogen 15 is dominating, heavy nitrogen. Also, if you look at argon 40 over argon 36, which is primordial, you get an enormous amount of argon 40 compared to Earth over argon 36. What this means is that some process produced a lot of heavy isotopes on Mars, even in the lower isotopic systems. Both nitrogen 15 and argon 40 are what are called radiogenic, produced by nuclear processes. So, sorry, I'm using this as a timer. Okay. Anyway, evidence for nitrogen argon. Well, if you irradiate an Earth-like atmosphere, you get a lot of nitrogen 15 and a lot of argon 40, as it turns out. So if you test for this hypothesis, just look for plutonium-244, product of our process. It's only got an 80 million year lifetime. Apparently the rocks on Mars, there's a rock sandwich they found. Half of it was irradiated by neutrons, half of it wasn't, and they're both about the same age. So about 180 million years ago, recent in geologic time. Here's Mars potassium map, radioactive potassium. You can see it has two hot spots in the north and then a spot at what's called the antipode, as if shock waves came from the spot in the north and concentrated in the south. Same with Mars thorium. They are basically overlays of each other. There's a lot more thorium and radioactive potassium on Mars surface than there is in the Mars rocks we get. So we have a Krypton uranium paradox on Mars. And so here are the two events that apparently occurred. In the north, they were over the ocean bed. They were airbursts. They didn't make craters. There are no craters at those sites of enhanced radioactivity. On Earth, we had something similar happen in Siberia, at Tunguska. Energy yield was 10 to the 15th, about a couple of megatons. If you estimate the amount released on Mars in these events, 20 to the 26 joules, 10 to the 25th joules from the Krypton. The Chicxulub impact was only 10 to the 23rd. This was 10 to 100 times more energy released than the Chicxulub event, which devastated the Earth. And it happened on a planet 1/4 the size of surface area. So the R process events would have been globally catastrophic if, in fact, that's what happened. Summary: Mars climate may have changed catastrophically. Evidence points to massive R process events about 180 million years ago. The R process events were airbursts, like Tunguska. Origin of R process events is unknown. Look for plutonium-244 in all the Mars samples. Now, suppose we find that plutonium-244. What do we do then? Well, the ISS consortium ought to go to Mars quickly. Both probes and boots on the ground. I know some people want to do everything robotically. We're talking about survival of not people on Mars, but our own survival on Earth. We want to make sure whatever happened on Mars doesn't happen here. Okay, Mars should become a permanent human settlement. Just for example, in 1971, Mariner 9 saw a global dust storm, covered Mars from pole to pole for months. It was discovered in early 1983. This could happen on Earth and end of a nuclear war, possibly. And this possibly prevented a nuclear war on Earth when we had the Able Archer crisis. Look it up on Wikipedia. It was a secret crisis. We were as close to a nuclear war as they were during the Cuban Missile Crisis. And you've never gone through a nuclear crisis until you've been working at a nuclear weapons lab and go through one. I'll tell you. Anyway, Mars saves humanity. This is all a metaphor I deal with in my novel, which is on sale in the bookstore. All sales proceeds go to Mars Society. Thank you.
If it was a airburst meteorite that caused these R events, it presumably was a meteorite as big or larger than the Chicxulub one. I wonder if the Mars atmosphere would have been much thicker than the Earth, because the Tunguska one was 100 meters or less. That's quite
Yeah. Yes.
The Chicxulub was several miles across and poured right through the atmosphere.
Yes.
So if it was bigger than Chicxulub, why wouldn't have hit the surface of Mars? Why would it have broken up in the
It's very mysterious. I don't know. And Chicxulub did not create any nuclear anomalies. It was just a big explosion. Neither did they looked in Tunguska. Everything they examined it with a fine-tooth comb. Believe me, the Russian government knows about nuclear science, and they found no evidence of any nuclear events associated with this airburst that happened over Siberia. But so I don't know. I'm sorry. This was an R process primarily, within the collateral explosion, the shock wave apparently going all the way around the planet. At least that is what the evidence indicates. It's a hypothesis, but the process that actually caused it, we have to find out. If they find the plutonium-244, we have to go up to Mars quickly. And yes, sorry.
I may have asked you this question before, but I recall your answer.
Nothing goes according to plan.
Yeah.
That's why plans are so essential and so useless at the same time. Yes, yes.
Report a few years ago about changes in isotopic ratios in solar wind by some unknown process.
The corona of the sun is a place where you can have kind of nuclear processes, and the sun itself, of course, that's our example of a fusion reactor, by the way, and it's rather turbulent and subject to every 11 years, its magnetic field completely flips and goes chaotic, and who knows what's happening down in the interior. Yeah, so I'm a plasma physicist. I look at the sun and I'm like, oh my goodness.
The plasma is not locally neutralized. The plasma does flow.
Absolutely. Plasmas, mind of their own. Once you understand that, then you understand why fusion has been proved so difficult to do. Yes. Thank you very much.